Alright, in this video I would like to go over the Flying Pig Lab and the background information for the Flying Pig Lab. So we're going to talk about the physics behind why the pigs spun around in a circle that was only attached in or onto a string that was suspended from the ceiling. First thing we have to do is we have to make a diagram of the Flying Pig Lab. And in this case, you will see that when the Flying Pig Lab starts to fly, the string that is attached to the Flying Pig Lab is coming out at an angle from the ceiling. And when the Flying Pig Lab, or the Flying Pig itself, starts spinning, it'll spin in a circle where it becomes a horizontal plane in the room. So this circle, the pig is flying in this circle at a constant speed, but a constantly changing velocity. And when it does that, there are additional forces that come into play. If we're going to draw a free body diagram of this, the pig will have a force of gravity, as always pointed down. But since the pig is not accelerating up or down, it's really staying in this circle, there has to be a balanced force in that opposite direction of the force of gravity. There also has to be a center-seeking force for the pig. If the pig is making this circular motion, there will be a force that is directed towards the center. This is what we will call some sort of centripetal force. The only thing holding this pig up is this force of tension, we're going to call capital T, coming from the string, and that is where these forces that balance the force of gravity and that force the pig to go in a circle come from. We're going to transfer this over to a different diagram, and this diagram is just going to show this triangle that we are basing our lab off of. This blue line represents the string, and when that force on the string is pulled at an angle, we can separate this triangle into two parts. One is the vertical and one is the horizontal. This makes a right triangle. We're going to label the blue line as T. We're going to label this horizontal part of breaking down the tension in the string as T in the X direction. We're going to break down the vertical part and call that T in the Y direction. If we do that and look at the diagram we have here, we know that this T in the Y direction goes for this vertical component of the triangle, and this centripetal acceleration going towards the center of the circle will represent the tension going in the horizontal component. So if we were to move on and try to really break this down in terms of how do we get an equation that'll give us the velocity, how are we going to find the velocity of this pig? Because that's one thing we can actually experimentally test as well, the velocity of a pig. And in this case, we'll see that T in the X direction is equal to the centripetal force, and T in the Y direction is equal to the force of gravity. Now, if we look at our equations that we know, the centripetal force is equal to the mass times the velocity squared divided by the radius. And the gravitational force is equal to the mass times gravity. All right. How then are we going to find and maybe get rid of this force of tension and use only values that we know? Because we can't really calculate the diagonal component of the tension. So we're going to use a little bit of trigonometry, and we're going to use the fact that the tangent angle of any triangle is equal to the opposite over the hypotenuse, or adjacent, sorry, opposite over the adjacent. And in that case, what is this symbol? That symbol is not a zero, that symbol is theta. And in this triangle, that angle is theta. And even in this diagram, our very first diagram, the angle that the pig and string make with vertical going down is called theta. So what is the opposite side length of that triangle? The opposite side length is tx. And what is the adjacent side length? The adjacent side length is ty. We were able to find tx and ty by looking at what forces were involved in this free body diagram. And if we take this equation and plug in this for tx and this for ty, we will get m times v squared over r divided by m times g for ty. And that is equal to tan theta. One of the purposes of this lab is actually to find a velocity, so we can compare an experimental velocity and a theoretical velocity. And in that case, we can solve for m, or solve for v. The m's cancel out. And in order to solve for v, we have to get rid of the r and g. So we'll multiply by r and g on both sides. We multiply by r and g on both sides. So the r and g's cancel out. You're left with v squared is equal to r times g times tan theta. In order to get v by itself, you square root both sides, and you get v is equal to the square root of r times g times tan theta. So that's just a little bit of background information for the Flying Pig Lab. What we'll also do is now figure out what could we have improved upon in the discussion section of our lab report.